2. So that is not 2n plus 1, that is 4n plus 2. So 4n plus 2, that equals to total number of pi electrons, total number of electrons that are involved in a delocalization. So 4n plus 2 equals to 6 if I put. So 4n equals to 4 I am getting, n equals to 1. N you should get integer. When you apply 4n plus 2 rule and n if you get integer, then the compound is aromatic. So this is one way to confirm whether the compound is aromatic or not. All the pi electrons that are involved in a delocalization must be in the same plane. Alright. Let's apply this 4n plus 2 rule to this naphthalene. How many total electrons that are in a delocalization? 10. 5 pi bonds are alternate. So if I apply 4n plus 2 to
n equals to
10, then what n I am getting?
2.
And I am getting 2, then this is also aromatic. So he gave a mathematical kind of the rule to find whether the compound is aromatic or not. So all those compounds which follow this rule, they are aromatic. What are the other points about the aromatic? Aromatic, they are unsaturated compound. They have pi bonds. They are cyclic, unsaturated. You know, they burn with the sooty flame. They have specific aroma order. Now these unsaturated pi electrons, they are in a delocalization. So there is a delocalization in aromatic compound. Delocalization of pi electrons, which is resonance. So there is a resonance in the aromatic compound. The pi electrons are in a continuous delocalization. For example, in case of the benzene, these pi electrons, they are in a delocalization. So if I draw another structure, this pi has to go this, there, the pi shift here, this pi shift here, and it gives another structure. Continuous delocalization. And you can draw the hybrid structure of this with the ring inside. That shows continuous delocalization. So that is another characteristic of the resonance aromatic compound. They have resonance. So this is how they differ compared to aliphatic unsaturated compound. Compound like propyne, compound like ethene. These are the aliphatic unsaturated compound. Their pi electrons are not in a delocalization. So if I compare reactivity, aromatic compounds are less reactive compared to this open chain aliphatic unsaturated compound. So that's why ethene decolorized bromine water, because it undergo addition with the bromine water. When we do reaction of ethene with the bromine, what will happen? The pi bond, it gets break. It undergo addition reaction and it forms CH2Br. CH2Br, it decolorizes bromine water. But benzene resists addition reaction. It does not undergo addition reaction with the bromine so easily. So it does not decolorize bromine water. You know, ethene decolorized potassium permanganate solution with the KMnO4, cold and dilute KMnO4, what it gives? If you remember this property, what it gives with the cold and dilute KMnO4? What ethene gives with the cold and dilute KMnO4? That is called Bayer's oxidation. It gives diol. What it gives? Diol. So it decolorizes potassium permanganate solution by forming diol with the KMnO4 in a cold dilute condition. So it is also addition reaction. Benzene does not undergo this kind of addition reaction with the KMnO4. It does not react with the KMnO4. It does not decolorize potassium permanganate solution. So conclusion, compared to open chain unsaturated compound, aromatic compound, they are less reactive towards addition kind of the reaction. And they undergo substitution kind of the reaction. In spite of having unsaturation, they tend to undergo substitution kind of the reaction. Now you can understand what kind of substitution is possible in case of the aromatic compound.
Nitrate.
If they do not undergo addition type of the reaction and if they undergo substitution kind of the reaction, what should be the attacking reagent? Which reagents should attack here? What should be the attacking species? What kind of the species can attack to this aromatic compound?
Nucleophile.
Electrophile. They have pi electron cloud. That is electron density negative charge. So if they are exposed to any electrophile, they are efficient species. They attack on the ring and they displace the hydrogen. So that kind of displacement reaction this compound tend to undergo, and they resist addition reaction. Understood? Can you draw mechanism of this electrophilic substitution? Try to draw the mechanism. How the reaction proceed? The hydrogen of this ring is displaced by electrophile, substituted by electrophile. So just think how the reaction will proceed.